Hi there. I welcome you once again to my YouTube channel and thanks for following my channel. Thanks for subscribing. I'm very grateful for that. So let's go on and then take a look at what we have for today. Today we are taking a look at how to find the LCM of two or more numbers. But this is another method. This method is similar to the product of primes. Alright, so we'll take a look at that and then let's dive into it and take a look at it. So let's take the question for today. The first question that we are going to use to learn this. So the question says we are supposed to find the LCM of, let's say, 36. LCM of 36. We have 48. Then we have 60. This is what we have. And we are finding the LCM of these three numbers. We are going to draw a table, and the table is going to guide us to help us find the LCM of these three different numbers. Alright, so let's do this. Let's do this over here. Let's write down the numbers we are going to find the LCM. We have 36, 48, and then 60. So we have 36, 48, and 60. Alright, so this is what we do. Now, we are going to take the prime numbers beginning from 2, then 3, 5, 7. Go through these numbers, alright? Check whether the prime number 2 can divide any of them. If you want to go with using 5, 5 can divide 60. So 2 can divide 36, 2 can divide 48 because they are even numbers. So 36 an even number, 48 an even number, 60 an even number. So 2 can divide all the three. It is not compulsory for you to select a particular number or a particular prime number that you are going to use to divide these. Okay, if the prime number can divide one of them, you are good to go. Let's begin with 2. So when 2 divides 36, what will be the quotient? When 2 divides 36, we have the quotient to be 18. So this prime number will be dividing these numbers over here, and that is what we are going to do. So 2 divides 36, we have 18. When 2 divides 48, we have 24. When 2 divides 60, we have 30. We are only dividing the numbers using prime numbers 2, 3, 5, 7, 11, 13, 17, 19. The prime numbers, that's what we are using to divide these numbers over here. You can't use 4, you can't use 9, you can't use 15. They are not prime numbers. So 2, 3, 5, 7, 11, 13, 17, 19. So the prime numbers, that's what we are using to divide these numbers here. All right. So we began with 2, and then there's what we have. Let's go through again. What prime number can divide these numbers? Or even one of them. What prime number can divide one of them? Over here, we use 2, and then here, let's use 5. Because 5 can divide 30, right? Though 5 can't divide 18, 5 can't divide 24 equally. It can divide 30. So you can even use it because it can divide one of them over here. You can still use the 5. So 5 can't divide 18. So repeat the 18 here because 5 can't divide it. Repeat it. 5 can't divide 24 equally. So repeat the same 24 over here. Now 5 divides 30 and then you have it to be 6. Let's come back here. Now 2 is going to divide all these. So 2 divides 18, you have 9. 2 divides 24, you have 12. 2 divides 6, then you have 3. At this stage, 9, 12, and 3. 2 can divide 12, but it can't divide 9 and 3. But you can still go on and use the 2 because it can divide the 12. But since 3 can divide all, I will go for 3. But you can still go ahead and use 2 to divide. Alright, just as we did over here. That 5 couldn't divide 18 and 24. So we repeated the numbers here. And then it divided 30 and then we had 6. So because 3 can divide all, I will go for 3, which is also a prime number. So we have 3 here. 3 divides 9, we have 3. It divides 12, we have 4. It divides 3, we have 1. Now we have 3, 4, and then 1. Over here, 3 can divide 3, but it can't divide 4 and 1. But you can still go ahead and use the 3 to divide. So we go on and use 3 because 3 is also a prime number. 3 divides 3, we have 1. Since 3 can't divide 4 equally, I will repeat the 4. Since over here we have only 1 left, I will just repeat the 1 because the 3 can't divide the 1. Alright, it is even less than the 3. So we just repeat the 1 that we have here. When it gets to the stage where you have it to be 1, it means you are done with the division. Alright, so over here we are done because we have 1, we are done. Over here too, we are done. So the only thing left over here is 4. And you can't use 4 to divide because 4 is not a prime number. 4 is an even number. So which of the prime numbers can divide 4 equally? That is 2. So 2 divides 1 is impossible. So we repeat the 1 over here. When 2 divides 4, we have it to be 2. And then when 2 divides 1, that is also impossible. So we repeat the same 1 here. The moment you have 1 appearing, it means you have got to the end of the division. So we just repeat that particular number there, 1, 1. So we are left with 2 here. 2 can divide 2, which is a prime number. So repeat using 2. When 2 divides this, it's impossible. So we write it down. 2 divides 2, we have 1. When 2 divides 1, it's impossible. So we repeat the 1 here. And that's what we have over here. Alright guys, so since we have 1, 1, and 1 here, the division is complete. We are done. So to find the LCM of these 3 numbers, what we do is we multiply the prime numbers that we used for the division. They are the ones here, from here to the bottom. Alright, we multiply all of them, and that will give us the LCM. The product, or their product, will give us the LCM. Alright, so we are going to multiply all of them and then use that to find the LCM. So let's select the prime numbers that are 2's. Okay, so we have 1, 2 here, we have 1 here. So 2 to be multiplied by, there's another 2 here, 2, which will be multiplied by, there is another 2 here, 2, which will be multiplied by another 2 here, 2, which will be multiplied by, we have 3 here, we have another 3 here. So we are done, and then we have 5. The last one is 5. So this is what we have finally. And with this, when 2 multiplies 2, we have 4. 4 multiplies 2, we have 8. 8 multiplies 2, we have 16. So let's bring it up here. The LCM is going to be 16. 2 times 2 times 2 times 2. We have it to be 16. 2, 2, 4, 4, 2, 8, and then 8 to 16. So after multiplying all these 2's, we have 16. Alright, and it will be multiplied by, when 3 multiplies 3, we have 9. 9 multiplies 5, we have 45. So we write it here, 45. So 16 multiplied by 45. Let's do it right here. So we have 45 and 16. Multiply 6, 5. We have 30. You write 0, remainder 3. 6, 4. We have 24 plus 3. We have 27. 1, 5. Then we have 5. 1 multiplies 4. You have 4. So we add them up over here. We have 0. We have 12. You write 2, remainder 1. 2 plus 4 is 6, plus the remainder of 1. We have 7. 720. So the LCM of these 3 numbers, alright, the LCM of these 3 numbers is 720. And that is it. We are done. So let me go back. Let me go some few steps back and then explain. We were told to find the LCM of 36, 48, and 60. And there's how we started. This method is like the product of primes because we are still multiplying the prime products over here. All right. So you go through the numbers and then you use the prime numbers to divide these numbers. And we started with 2. 2 divided 36, we had 18. 2 divided 48, we had 24. And then 2 divided 60, we had 30. So with this, 2 divided these, and then we have these ones, okay? And then when we went through over here, we could have used 2 because 2 is a prime number that can divide 18, can divide 24, and can divide 30. But I went for 5 because 5 can divide 30, and you can do it like that. Though 5 can't divide 18 equally, 5 can't divide 24 equally, 5 can divide 30. 5 is also a prime number. So once it can divide one of them, you can use it to divide. So the ones that it can't divide, you repeat the numbers because 5 can't divide 18 equally, repeat the 18. Because 5 can't divide 24, repeat 24. Now when 5 divides 30, you have 6. Then we go on, we use 2 over here because 2 can divide all of them. You can't use 5 because 5 can't divide any of them, and you have to repeat the same numbers here again. So there is no need. So we use 2. 2 divided 18, we had 9. Divided 24, we had 12. Divided 6, we had 3. And then over here, we chose 3 because 3 is the prime number that can divide all the numbers over here. You could have gone ahead to use 2, right? But I went for 3. So 3 divided 9, we had 3. 3 divided 12, we had 4. 3 divided 3, we had 1. And then over here too, we went for 3. 3 divides 3, we have 1. 3 couldn't divide 4, so we repeated the 4 here. 3 couldn't divide 1 equally, we repeated the 1. Then we went for 2 here. 2 couldn't divide 1, so we repeated the 1 here. 2 divides 4, and then you have 2. 2 divides 1, it's not possible, so we repeat the 1 here. We went for 2 again, because when you get to the point where you have the quotients over here to be 1, it means that it has come to the end of the division for those numbers, all right? So over here, it is only 2 that we have to divide, so we have to go for the prime number 2 to divide these 2. We didn't use 4 to divide here, because 4 is not a prime number, and we are using only prime numbers to divide them. So 2 divides this 1, it's not possible, you repeat the 1. When 2 divides 2, you have 1. When 2 divides 1 over here, it's not possible, so you repeat the 1. Now we have 1, 1, 1. We have come to the end of the division. So we multiply all these prime numbers here to obtain the LCM of these 3 numbers. And then we root out all the 2's and then the 3's, all right? And then multiplied by the 5. So the product is what we have here. That's what we have here. So 2 multiplies 2 multiplies 2 multiplies 2, you have 16. All right, 3 multiplies 3, you have 9. 9 times 5, you have 45. And then 45 will multiply 16. And then the product over here is 720. So the LCM of these 3 numbers is 720. The LCM is 720. That is the LCM.